Greetings, everyone, and welcome to section 8.3, undetermined coefficients. By now we've talked about a differential equation of this form to have a solution that's of this form, complementary solution plus the particular solution. Today, we look at finding yp of x, and then we'll use it using guess and check method known as undetermined coefficients. Now, we will not be using anything about an annihilator or anything like that. We're just going to use undetermined coefficients to find the solution for yp of x. Now, if you consider y double prime plus 16y equals 7e to the 3x, and you want to find the particular solution to that differential equation, what you have to ask yourself is what function times 16 and added to its second derivative makes 7e to the 3x. So if you look at yp of x being cosine or sine, if I take two derivatives of that and add it to 16 times itself, I'm not going to get an e to the 3x. I'm going to get a sine or a cosine. Okay, what about if I look at e to the 4x? Okay, well, if I take two derivatives of a e to the 4x, I'm going to get an e to the 4x. So that doesn't make sense either. The only thing of those options that you would try is a e to the 3x, because when I take two derivatives of a e to the 3x, I get an a e to the 3x. Now, how does that work? Okay, this is the first example we're going to look at. We worked all the way through. If y equals a e to the 3x, then y prime is 3a to the 3x, and y double prime is 9a e to the 3x. And making the appropriate substitutions, you can see that a is 7/25. In other words, yp of x is 7/25 e to the 3x. So when you add the particular solution to the complementary solution, remember that's what you get when the right-hand side is equal to 0, you would get the general solution to be c1 cosine 4x plus c2 sine 4x plus 7/25 e to the 3x. Okay, so it goes a little bit like that. Now there's some tweaks along the way that we have to go through, but basically that's the overall gist of how these problems are done. Okay, so let's look at one of those. Okay, look at y double prime minus 9y equals 5e to the 3x. What is going to go wrong if you try a e to the 3x? Well, it's simple. Okay, look at the complementary solution. So if we were to solve this differential equation, y double prime minus 9y equals 0, and that has auxiliary polynomial r squared minus 9 equals 0, you see that r is plus or minus 3. That means the complementary solution is going to be c1 e to the 3x plus c2 e to the minus 3x. Okay, well, if we try using a e to the 3x and plugging it into the left-hand side is going to be 0, because any constant times e to the 3x, when multiplied by 9 and after you take two derivatives and subtract the difference, you're going to get 0. And 0 can never equal 5e to the 3x. So what are you going to do instead? The answer is you're going to try ax e to the 3x. Okay, so let's take a look and see how that works. If you have ax e to the 3x, so y equals ax e to the 3x, y prime is going to be, now product rule, make sure you're good at this, a e to the 3x plus ax times 3e to the 3x. So you simplify this, you get a e to the 3x plus 3ax e to the 3x. Okay, and that's what y prime is. What's y double prime? Take the derivative of this. Okay, so you get 3a e to the 3x plus 3 times the derivative of ax e to the 3x. Well, I don't need to reinvent the wheel. I've taken the derivative of ax e to the 3x. I did it right here. So that's going to be a e to the 3x plus 3ax e to the 3x. Okay, now combine your like terms. I have 3a e to the 3x and 3a e to the 3x. That's 6a e to the 3x plus 3 times 3 is 9 ax e to the 3x. Okay? Now, plugging that into our differential equation, we get y double prime, so that's 6a e to the 3x plus 9ax e to the 3x minus 9 times y ax e to the 3x equals 5 e to the 3x. Okay, so I'm taking all of this and I'm plugging it into y double prime minus 9y equals 5 e to the 3x. Okay, so what does this become? The 9ax and the minus 9ax, that's going to cancel out. You're going to be left with 6a e to the 3x equals 5 e to the 3x, and guess what? A is going to be equal to 5/6. Okay, so that is going to be the particular solution. Okay, let's see. Adding this all together, I'll put the particular solution here in red. So our general solution is going to be y equals, for some reason I used a's and b's, so let's try that. A e to the 3x plus b e to the minus 3x plus 5/6, that's what a is, x e to the 3x. So green is the complementary solution, red is the particular solution, red and green makes the general solution. Okay, now a little summary of that reads as this. Okay, the lesson here is if the non-homogeneous term is itself part of the complementary solution, the first attempt won't work. A modification must be made, and what are you going to use to modify it with? Well, let's take a look. If the f of x is of the form constant e to the ax and a e to the ax doesn't work, try ax e to the ax. If the right-hand side is either c cosine bx or c sine bx, and this particular solution doesn't work, multiply by x, ax cosine bx plus bx sine bx. Last one, if the right-hand side is of the form cx to the k, and this polynomial doesn't work, try multiplying it by x. So in each case, your next attempt is going to be x times your first attempt. And your first attempt should be this in each case. So we have 4 questions here. Okay, find the general solution to y double prime minus 9y equals 5 cosine 3x. Let's take a look and see what that looks like. Part A, y double prime minus 9y equals 5 cosine 3x. Okay, so let's do complementary solution first. Okay, if we do a complementary solution, then we're acting as though this is equal to 0, and our auxiliary polynomial will be r squared minus 9 equals 0. So r is plus or minus 3. Okay, now if r is plus or minus 3, our complementary solution, I'll make this my general solution. If r is plus or minus 3, okay, is going to look like a e to the 3x plus b e to the minus 3x. And everything right that's left over right here is reserved for our particular solution. Okay, so let's find out what the particular solution is. The right-hand side is of the form 5 cosine 3x. So our first attempt is going to be, I will go back to using C's, C1 and C2. There we go. Is going to be A cosine 3x plus B sine 3x. Okay, sorry for switching constants on you. I had thought in reviewing my notes that the complementary solutions were A's and B's. They're actually C1s and C2s. Okay, so first off, particular solution is some constant times cosine 3x plus B times some constant, B times sine 3x. Okay, y prime is derivative cosine is minus sine, so minus 3a sine 3x. And this is 3b cosine 3x. Take another derivative. You're minus 3a cosine 9a cosine 3x minus 9b sine 3x. Okay, using that information here, we can make the substitution into our differential equation that says minus 9a cosine 3x minus 9b times the sine 3x minus 9 times, what's y? That's a cosine 3x plus b sine 3x is equal to 5 cosine 3x. Okay, let's combine like terms. Okay, on the right hand side I have left hand side, I have a cosine 3x here, and I'm going to have a cosine 3x there, so I'll have minus 18a cosine 3x, and there's a sine 3x right here, that's minus 18b sine 3x, and that's going to be equal to 5 cosine 3x. Okay, so if you match up term by term, we have no sine 3x's right here, so we can say that minus 18b is equal to 0. Here we have negative 18a cosine 3x's, and that's equal to 5 cosine 3x's. So it looks like a is going to be negative 5/18, and b is going to be 0. So plugging that back into yp of x, okay, that term vanishes, and started in red, I'll finish. We'll get minus 5/18, and a is cosine 3x. There you go. Let's do another. Letter B. Y double prime plus 9y equals 7 sine 3x. So again, we start off with a complementary solution. R squared plus 9 is equal to 0. So R equals plus or minus 3i. In the last video, I alerted you that, auxiliary polynomials that produce roots like these should produce an instinctive solution where you don't have to recreate everything. So let's say it's C1 sine 3x plus C2 cosine 3x as our complementary solution. Now, what are we going to do? We're going to set up our particular solution. Our particular solution should be a cosine 3x plus b sine 3x. Now, we know that what we learned in the one of the previous examples, that this setup right here, when plugged into y double prime plus 9y, is going to output 0. So our first attempt would be a cosine, can you see what I'm looking at now? That our first attempt should be a cosine bx plus b sine 3x, okay? But the lesson learned here is if the non-homogeneous term, this one right here, is itself part of the complementary solution, which it is, it's right there, then the first attempt won't work and a modification must be made. So instead of going down the first route and doing all of this work, let's start with our modification. Let's make this a x cosine 3x and bx sine 3x. Okay. Good news and bad news. One is we won't do a bunch of unnecessary work. Two, bad news is we're going to do a bunch of work. So what's y prime? Okay, well, it's the product rule. It's the derivative of ax is a cosine 3x plus ax times the derivative of cosine 3x. So that's minus 3 sine 3x plus b sine 3x plus bx times the derivative of sine 3x. That's 3 cosine 3x. Okay, now I'm going to clean this up before I take a second derivative. So that's a cosine 3x minus 3ax sine 3x plus b sine 3x plus 3bx cosine 3x. That's only y prime. It's y double prime. All right. Let me take one quick look here, see if there's anything I can do before. There might be one thing I can do to make my life just a bit easier. What if I were to do this? Combine these terms. Say that this is a plus 3bx cosine 3x plus b minus 3ax times the sine of 3x by combining these two terms. Typically I do this by brute force, but I'd like to see how this works. Take the derivative of this part. Okay, it's the derivative of the first term. Constant is 0. Derivative of 3bx is 3b times the cosine of 3x plus the first term, a plus 3bx times the derivative of this term. So that's minus the sine, minus 3 of the sine of 3x. Plus, okay, the derivative of this is going to be a negative 3a times the sine of 3x plus b minus 3a x times 3 cosine 3x. Right. So now let's clean all this up and see what it boils down to. 3b cosine 3x minus 3a sine 3x minus 9bx sine 3x minus 3a sine 3x plus 3b cosine 3x minus 9ax cosine 3x. Wow, that's a lot. Okay, are there like terms that we need to look for? Looks like we have 3b cosine 3x's. So that'd be 6b cosine 3x. See if there's minus 3a's. There's 2 minus 3a's, so it's minus 6a sine 3x. There are a negative 9bx sine 3x and a minus 9ax cosine 3x. There you go. That's y double prime. And to that, I have to add 9 times y. So I'm just going to do this here on the left side, 9 times y. Okay, what's 9 times y? 9 times y is 9 times ax cosine 3x. Oops, you can't see that. 9 times ax cosine 3x. So you get 9 ax cosine 3x. And you get 9bx sine 3x. And very fortunately, those will zero out. So y double prime p plus 9yp is equal to 6b, that's a b, cosine 3x minus 6a sine 3x. And all of that is supposed to equal 7 sine 3x. So 7 sine 3x is equal to 6b cosine 3x minus 6a sine 3x. So what does that tell you about b? Well, 6b is going to equal 0. There's no cosine 3x's over here. And minus 6a is going to equal 7, so a is equal to negative 7, 6. So in red, negative 7, 6 times what? That's a, so x cosine 3x plus, and b ends up being 0, so I don't need to include anything there. And there's our general solution. Okay, so that's as good a point as any to hit the pause button and make sure this video doesn't go any longer so that I save room on my iPad so it doesn't cut off halfway through. So I'll get this uploaded and we'll continue this lecture next time.